Ladies and gentlemen, we are now in 6-3, elimination using multiplication. In this section, the problems are going to get a little bit more complicated, not a ton more complicated, but you are going to have to add an additional step in order to use the elimination. We're still going to be adding or subtracting equations from each other, but there's an additional step. Let me show you how. So here's our problem. I want to solve this using elimination. I've got 5x plus 6y equals negative 8 and 2x plus 3y equals negative 5. Now here's my problem. If I simply add or subtract these, I'm not going to be getting rid of one of the variables because I got 2x's here and 5 here. I can't subtract it. I can't add it. I've got 6y's here and 3y's here. Once again, if I add or subtract, it's not going to eliminate one of the variables. So what I need to do first is I need to multiply one of the equations by the same thing throughout the entire equation. We know already, this is background here, we know already that we can do this. 3x equals 6. We know we can multiply the whole thing by 2 because here x equals 2. If we multiply the entire thing by 2, we get 6x equals 12. So you have absolutely no idea, but I just stepped away for 20 minutes and I don't remember where I was. Oh yeah, we're over here. We're looking at this. We are looking at 3x equals 6 that I multiplied by 2 because here I got x equals 2. If 3x equals 6, I divide by 3, both sides get x equals 2. But I can multiply the entire equation by 2. So then I get 6x, because 3x times 2x is 6x. 6 times 2 is 12. And then I divide by 6, and I get x equals 2. See the exact same thing. So as long as I do the same thing on both sides, I'm fine. That's why I can use this system. So now let's back up and just look at this problem. So I know, so as I'm looking at this, I'm looking for multiples. I think of things like factoring, and I think of greatest common factor and things like this. I'm looking, and I can tell that this 6y, whoa, I do not want it nearly that big. That's crazy big. Sorry about that. The program still surprises me sometimes. So this 6y and this 3y are different by a factor of 2. So I'm going to multiply this second equation by 2. 2 times 2x. So I'm going to I'll write it like this. I'll write it 2 times 2x plus 3y equals negative 5. I'm multiplying by the entire thing. So 2 times 2x is 4x. Then I put my plus. 2 times 3y is 6y. And then 2 times negative 5, I put my equal sign. 2 times negative 5 is negative 10. So now I'm going to bring down my other equation, which is 5x plus 6y equals negative 8. And you can see now we can subtract the two equations. So I'm going to put the subtraction sign here. 4x minus 5x is negative x. 6x minus 6x, or I'm sorry, 6y minus 6y, I've got no y left. Then my equal sign, negative 10 minus negative 8. So since it's minus a negative, remember, minus a negative is the same as a positive. So negative 10 plus 8 is negative 2. So now I've got negative x equals negative 2. I don't care what negative x is, I care what x is. So I know x equals 2. And now I'm just going to follow the same procedure that I used last time. So really, we're just adding this one additional step. And once we add this step, it's exactly what we did in the last section in 6-2. So now I've got x equals 2. I can stick it into, let's say, into the first equation. 5x plus 6y equals negative 8. 5 times 2 plus 6y equals negative 8. 10 plus 6y equals negative 8. And then I subtract 10 from both sides to get 6y equals negative 18. And then I divide both sides by 6 to get y equals negative 3. So my answer is 2 comma negative 3. Now to check to see if that works in this equation, I'm going to take the second equation, if it works in the system. So 2 times x, x is 2, 2 times 2, plus 3y plus 3 times negative 3 equals, right here, negative 5, negative 5. So 2 times 2 is 4, plus 3 times negative 3 is negative 9 equals negative 5. Is this a true statement? Is 4 minus 9 negative 5? Yes, it absolutely is. So that verifies that this is the correct answer for my system. Now I'm going to do another one, and this one, I'm not even going to lie to you, this one is annoying. in order to solve with elimination. Now, actually, this is page 358 in your book, not 357, like it says at the top of my screen. But see, look at this. We've got 4x and 3x, and we've got 2y and 3y. What are we going to do to get rid of something? We don't have a nice way that we can do this. We're going to have to multiply both of the equations by something. Oh, so much of a problem. Now, one thing that's easy, though, is we can choose which way we want to do it. We can choose if we want to eliminate x first, or we can choose if we want to eliminate y first. As long as you don't break math, don't break math. As long as you don't break math, we are absolutely fine. We can do it any way that we want to. So let's start out by getting rid of x first. I'm going to solve it both ways just so you can see it works both ways. To get rid of x first, I've got, whoa, I don't want to do that. I've got 4x's here and 3x's here. What is the least common multiple of 4 and 3? Well, 4 times 3 is 12. We don't have any common multiples less than that. So I'm going to have to turn both into 12x. So to get this equation to say 12x, I need to multiply by 3. To get this equation to say 12x, I need to multiply by 4. So I'm going to do 3 times 4x plus 2y equals 8. So I distribute the 3. 3 times 4x is 12x. 3 times 2y plus 6y equals 3 times 8 is 24. My second equation, I do 4 times 3x plus 3y equals 9. 4 times the 3x is 12x. That's exactly what I wanted. 4 times the 3y plus 12y equals 4 times the 9 is 36. So now I've got a new system set up. My system is 12x plus 6y equals 24, and 12x plus 12y equals 36. Now notice that that is the exact same. It is equivalent to the system that I started with. But now I can use elimination. I'm going to subtract these from each other. 12x minus 12x, I got nothing. No x left. 6y minus 12y is negative 6y. Equals 24 minus 36 is negative 12. Now I divide by negative 6 on both sides to get y equals 2. So I stick y equals 2 back in. Now I've got many options for where I stick it back in. I could stick it back in here. 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 You know what? Let's just choose this one to stick y back in. So I've got 4x plus 2y equals 8. 4x plus 2 times 2, because my y is 2, equals 8. 4x plus 4 equals 8. Subtract 4 from both sides to get 4x equals 4. Divide both sides by 4 to get x equals 1. So my answer is 1, 2. I am not going to do the check step on this one because my page is completely full. So I will trust that you can do the check step and find out that that is the correct answer. The point is 1, 2. So now I'm going to solve that same problem. Remember we found out our answer is 1, 2. I'm going to solve the same problem by eliminating the y first. So over here, I've got a 2 and a 3 in front of the y. My coefficients are 2 and 3. The least common multiple between 2 and 3 is 6. So I need to multiply this by 3, and I need to multiply this one by 2. So I'm going to rewrite these here. I've got 3 times 4x plus 2y equals 8. 3 times 4x is 12x plus 3 times 2y is 6y equals 3 times 8 is 24. And then I've got 2 times 3x plus 3y equals 9. 2 times 3x is 6x plus 2 times 3y is 6y equals 2 times 9 is 18. So now my system, which is equivalent to my original system, my new system is now 12x plus 6y equals 24, and 6x plus 6y equals 18. So I need to subtract them to get rid of my y. 12x minus 6x is 6x. 6y minus 6y, I've got no y left. and then I put my equal sign. 24 minus 18 is 6. So now we have 6x equals 6. I divide both sides by 6 to get x equals 1. Hey, look at that. X equals 1, same as over here. So now let's substitute. I'm going to substitute it into this equation this time. Just for giggles. You know, I could really substitute it many places. We know that by now. So I've got 3x plus 3y equals 9. 3, and my value for x is 1, plus 3y equals 9. 3 plus 3y equals 9. And then I subtract 3 from both sides to get 3y equals 6. And what do you know? Y equals 2. Yay! So once again, my point is 1, 2. So I'm saying yay, not only because we get the same answer, but because Mr. Weldy did not make a mistake. And so I went through this all first draft, and I'm just very pleased with my own self right now. So hopefully you're pleased with yourself also. This is the section. I will tell you the absolute best way to do this is practice, 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 practice. You are not going to get it off the top of your head. Practice, 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 practice. And after you're done with that, practice.